Hello everyone. Okay, so today we're going to look at the derivative of inverse functions. So for instance, we have here f of x is 1/2 x cubed plus 3x minus 4, and h is going to be the inverse of function f. And I'm also telling you that f of negative 2 is negative 14. So if I substituted negative 2 into the function f, I would get the answer negative 14. But I want you to find the derivative of h, which is negative 14. So the derivative of h at negative 14 is really the inverse function, and we take that derivative evaluated at negative 14. So that's what we're really looking for. Now the problem is, it's not so easy to find this inverse. If I had given you a function f of x is x squared and asked for the derivative of this inverse at, say, 4, okay, we would say, all right, well, my function is y equals x squared, so my inverse, I switch my x and my y. I solve for y by taking the square root of both sides. That's no longer a function, so if I want an inverse function, I'd have to restrict the domain. Let's say the square root of x when x is greater than 0, okay, since we want to use the 4. And then we could say, now that we know that f inverse of x is the square root of x, or really x to the 1/2, then our derivative with respect to x of f inverse of x is 1/2 x to the negative 1/2, or 1/2 radical x, so that now I can take this and say, okay, that's 1/2 radical 4, which gives us 1/4. A lot of work, but can be done. And that was for a simple function, f of x is x squared. So what happens when we don't have a simple function? How do we find the derivative of that inverse? That's what we're going to look at today. So here we're going to use the chain rule to develop the rule, okay, if we know that f and g are inverses. Now, how do I know that f and g are inverses? If you recall the definition of inverses, if f and g are inverses, then f of g of x is the same as g of f of x, which is x. The inverse functions undo each other, and you wind up back at the x value you started at. So we can either tell you f and g are inverses, and then you can conclude that f of g of x is x, or I could tell you that f of g of x equals g of f of x equals x, and then you know that f and g are both inverses. So what we want to do here is we know this, so we're going to take the derivative with respect to x of both sides. Now on this side here, we're going to use the chain rule, and that's going to give us f prime of g of x, keep the inside, times the derivative of the inside equals, and on the other side, the derivative of x is just 1. Now, what I'd like to do is solve for g prime of x. So if I want g prime of x by itself, I have to divide both sides by f prime of g of x. So now remember that this g prime is really f inverse that we're taking the derivative of. And we have developed the rule for the derivative of an inverse function. So the derivative of an inverse function here, if g of x is the inverse of f, then we find the derivative by doing 1/f prime of g of x. Now remember, g of x is a y value of g, but it's also an x value of f. And if we look at it in this form, that whatever this x is, so this up here is an x value of f inverse, okay? But it's a y value of f, which is why this, when we put this x into the inverse, now the whole thing, that's the x value of f because it's the y value of the inverse. Now there's a little acronym here, IDDI. It's the inverse, derivative, derivative, inverse. So we have the inverse and we want the derivative, then it's 1 over the derivative of the inverse. So sometimes that helps people remember what to do. It's up to you whether or not you want to use that. But I would like to go back to that first problem and see what we can do with this, okay? Remember, we want to find h prime of negative 14. That is this g of x. So it's supposed to be 1 over f prime of h of negative 14. True? Okay. So in order to do that, I always like to find my x of f first. This value here is the y of f. So I know that f of x is going to equal negative 14. And look at this. We know that when x is negative 2, f is going to be negative 14. Also, if we know, another way to look at that, if we know that for f, we have negative 2 is negative 14, then we know that h, switch the x and y's, of negative 14 is negative 2, and either way, we're going to get 1 over f prime of negative 2. So now we need to find f prime. So we had f of x is 1/2 x cubed. So the derivative of 1/2 x cubed is going to be 3/2 x squared plus the derivative of 3x is 3 and the derivative of negative 4 is 0. Now we're going to take that derivative and we're going to substitute in our x value negative 2 and we're going to get 3/2. Negative 2 squared is 4 plus 3. That's going to give us 6 plus 3, which is 9. So that means 1/9 is the derivative of h at negative 14. Yay! G prime of f of x equals 1 over the derivative of f of x. Now it's important to remember here, guys, that this f of x is a y value of f. This x is an x of f. All right, that's real important to make sure you know. Now, not only that, another way we can write that, so since f of x is a y of f, we can write g prime of y. Not really the best notation, but every once in a while you'll see somebody write it. And another way to write that is the derivative with respect, because remember g was just f inverse. So the derivative with respect to x of f inverse of x equals 1 over f prime of x. But again, notice there's two x's in here. But when you have an inverse, an x of the inverse is a y of the original function f. That's really important to be aware that these x's are not the same number, okay? Real important. Let's try a problem. This is an old multiple choice question. It's from 1988. So they're telling us that if g of negative 2 is 5 and f prime of 5 is negative 1/5, they want us to find g prime of 2. What I forgot to type here is f and g are inverses. So if f and g are inverses, then g prime of negative 2 is going to be 1 over f prime of g of negative 2, right? Now what is g of negative 2? G of negative 2 is 5, so it's 1 over f prime of 5. So this is just the reciprocal of f prime of 5. And if we know that f prime of 5 is negative 1/5, then its reciprocal is negative 5. And that is the derivative of g at negative 2. That's it. Now here, with this example, I'm going to give you a more structured way to go about the problems, okay? So f of x is x cubed plus x, and we want to find the derivative with respect to x of the inverse of f of 2. Now remember, this 2 is a y value of f. So the first thing you want to do is find the matching x value. So if we take f of x is x cubed plus x, the y is 2. We need to find x. So let's see. I think the only number that when I cube it and add it to itself that gives me 2 is going to be 1, right? And you can check me on the calculator if you want to graph it or use C poly roots. The next thing we're going to do is we're going to find f prime of x. Okay, so the derivative of x cubed is 3x squared plus the derivative of x is 1. Now we're going to take that x value we found and we're going to plug it into the derivative. So it's 3 times 1 squared plus 1, which is 4. The next step is to actually find the derivative of the inverse at 2. The way we do that is that we take the reciprocal of f prime of 1. So all it is 1 over 4. So, to repeat, we take the y value that they give us in an x position, because it's the inverse function. We find the matching x of f, we plug that into the derivative of f, and then we take the reciprocal. Let's try another one. Okay, last one. So here's f of x, and we want the derivative with respect to x of f inverse of 0. Now this 0 is a y of f. So the first thing we need to do is find the matching x value. So x to the 5th plus 2x cubed plus x plus 4 equals 0. You can use your C poly roots, you can use your graph, whatever you want to do. Find that root. And it should be negative, okay? Next step, we find f prime of x. Derivative of x to the 5th is 5x to the 4th, plus the derivative of 2x cubed is 6x squared, plus the derivative of x is 1, plus the derivative of 4 is 0. Then we're going to take this new x value and we're going to plug it into the derivative. So 5 times negative 1 to the 4th, plus 6 times negative 1 squared, plus 1. That's going to give us 5 plus 6 plus 1. That's 12. Now we're ready to give the derivative of the inverse at 0. It's just the reciprocal of 12, 1/12. That's it, guys. All right? So there we are. We found how to find the derivatives of inverse functions without having to find the inverse itself, because sometimes it's really hard to switch the x and y's and solve for y. So it's easier to be able to find the inverse function. You find the matching x value, find the derivative at that x value, and then take the reciprocal. All right, guys, have a great night.